Hello, everyone. So, we're going to continue our discussion on significant figures today. And now we are going to be looking at decimals. So, in the previous video, we looked at these really big numbers. We're looking at population sizes, which were in the tens of millions. Now, for the first part of this video, I want to shift gears to look at things of numbers of a very, very, very small size. Now, I'm all about giving you guys context. So, obviously, we will get to the significant figures. But before we do that, I want to put you in the shoes of, say, a microbiologist, right? And you are measuring the size of a particular bacteria. So we'll see, especially for this part of significant figures, as well as the other one too, to an extent. But when we approximate, and also when we look at decimals in the context of significant figures, they're often to do with measurement. So what we're going to look at here is as measuring, for example, as you being a microbiologist, you're measuring the size of a certain bacteria. And one measurement you get, so this tiny, tiny, tiny bacteria, you have these tiny measuring instruments, you're looking through a microscope, you're doing all that sciencey stuff, right? And you measure this to be 0.00003635 meters. So this is a size in micrometers, right? This is tiny. So we have these even smaller units when dealing with these really small things. But I'm going to throw out a question for you, and you kind of pause and ponder this idea. Which of these numbers do you think, with just this number laid out, do you think are significant? Or how many significant figures would you say there are? So if you've had a thought about it, that's good. If not, let's just jump straight into it. So I'm going to answer your question with another question. What if okay, let's assume that all of these figures are significant, because you could say, well, these zeros are important, which they are, and because of that, I'm going to say that all of these figures are significant. Now, that's cool, but what if we didn't have our non-zero digits, right? This thing here is not really telling us too much, because a zero is redundant, right? These zeros could go on forever. And this figure won't be significant. Well, this measurement tells us nothing until we throw in some non-zero figures. Because those are the ones that, while yes, these zeros are important, those are the ones that give context to all these zeros. Because the fact that we measured 3635, I think it was, these figures that we got now give us context to say, okay, well, this was something on the microscopic level. It was on the level of micrometers, right? That's the unit. Because we don't have to go too much into unit conversions. I know I'm diverging a little bit, but these numbers are the important ones. They're the significant ones. And these zeros, at least when we have a 0.00000, they act in the same way that these zeros did in our previous video. they weren't significant because the non-zero ones actually gave some context to the level of to the accuracy of the measurement, right? So in the same way, these zeros are not significant figures. So we are left with 4 significant figures in the measurement we made of our particular bacteria. 4 sig figs. Cool. Now let's have a go at practicing, for a bit of revision, what we know about significant figures. So let's have one example. I'll get you to round this to 1 significant figure and 2 significant figures. So have a pause, have a go if you'd like. This is just a bit of revision. But what we would have gotten is that, well, the very first number that is of importance to us as we go in this decimal direction is our 3 here. So if we were to round this up, well, we would get we have a 6 here. So obviously we will be rounding up. So the measurement we're going to get, if we didn't need to be too accurate, we just needed 1 significant figure for the data we have in the lab that we're measuring this bacteria in, well, we only need it to 1 significant figure. So we would get a measurement of 0.00000. Is that enough zeros? It is. 4 meters. That is as far as we need to go. Because we have said, your boss, for example, the head scientist has said, well, we only need it to 1 significant figure. So that's cool. We're done here. Now, maybe that wasn't enough to make any make, I guess, any kind of statement about the bacteria size. So your boss comes back and says, "Oh, we need it a little bit more specific. The 0.0000004 meters you had, let's just get it a little bit closer to the actual value." So you'd say, well, okay, I need 2 significant figures. There's one there. That's my second significant figure, 1, 2. And the next number here is less than 5. So we'll round down. And you come back to your kind of head scientist, your boss, and you say, well, here is our number to 2 significant figures. And lo and behold, as we noticed in the trend before, that the more significant figures we have, the closer our number is to the original one we measured. So once again, we're in control of the level of accuracy. And especially with significant figures, they're very beneficial to people like scientists who are dealing with these very large and very small numbers. So the context is important. And this is where significant figures may be more useful, as in talking in terms of significant figures, rather than to, say, decimal places. So this is correct. This first one here is correct to 1, 2, 3, 4, 5, 6 decimal places. So we no longer have to say, okay, correct to 1 decimal place. Oh, wait a minute, 2 decimal places, 3, 4, and do the counting. We can say 1 significant figure and you already know what we're looking at. We're looking at the first non-zero number following all of these zeros. So that's part 1. Now, one more case we're going to look at is the idea of a ruler. So a lot of you, if you go to school and you're doing maths, it'll be compulsory for you to have a ruler for certain measurements. And some of you may have, all of our rulers are 30 centimeters, but some of you have it just in centimeters. You have it to one certain degree of accuracy where you have, 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters, etc., all the way up to 30. Obviously, this isn't to scale, but some of you may have these little notches, these little millimeter kind of notches, and 10 of those make up the 1 centimeter. So if we were to say measure a straight line, so I'm measuring a straight line from here to here. I know that it's going to be 4 centimeters, right? Now, if I were to write this down, right? Using my regular ruler that was just in centimeters, I can just write 4 centimeters, done. That's all I need, right? Because that's the units to which I'm measuring. That's the level of accuracy that I've chosen. But say if we wanted to make it more specific and you had this millimeter ruler now, well, you would tell me that, well, I measured this to be exactly 4.0 centimeters because I now have a millimeter ruler. I know that this is not 4.1, not 3.9, etc. I know that this is in millimeters. That is my scale. So I know that, sorry, get rid of these little dots. I have a further level of accuracy. So here, as opposed to the one significant figure I had up here I have two significant figures because this 0, in the context of a centimeter and millimeter ruler, it's important now. It's an added level of accuracy because there's less room for approximation because the millimeters confirm that. These little notches here tell us a lot. And the smaller the scale that we use, when we go into micrometers and nanometers, these tiny, tiny, tiny scales, we are learning more about the accuracy of our measurement. If this was something like, if we're measuring this on a micrometer scale, 4.00000, I think that's enough, but we have way more significant figures. We know exactly that we know exactly, sorry, it's hard to explain, but we know for a fact that our measurement, if we did it on a scale of micrometers, was more accurate than something like centimeters. So these zeros at the end of these 0 decimals at the end tell us more about accuracy. So let's do one more example just to clarify this. If we were to look at a number of, let's say, okay, let's go example 2. If we wanted to round 27.503, let's say this is centimeters. Let's round this to, well, first of all, we know that there are 5 significant figures here. There is 1, 2, 3, 4. Oh, yeah, 1, 2, 3, 4, 5. Because the 0 here is important. It tells us a more exact thing about our measurement. But rounding this, say, to 4 significant figures, right? Well, this one's significant, this one's significant, this one is, and so is our 0 here, because that's the level of accuracy that we've laid out. That we will say, okay, well, this is a 4 significant figure level of accuracy. So we're going to be rounding this number, and obviously we'll round it down. So we'll get 27.50 centimeters. So we can see this 0 now it is significant. It has been made significant. And this is where it gets a bit tricky, guys. Part B. Oh, sorry, I should write this as to 4 significant figures. 4 significant figures. And we're going to do 3 significant figures. And this will be, well, we're only looking this far. We only need 3 significant figures. So our 0, obviously that's less than 5, so we're going to round down. And we will get 27.5 centimeters. Well, some of you may go, well, these two numbers are exactly the same. This 0 isn't contributing anything extra to our measurement of 27.5, and you would be correct in saying that. But all our significant figures are doing is defining the level of approximation, the level of accuracy we have chosen. So it's all to do with the measurement that we state. And I know I sound like a broken record repeating this, but that is why significant figures are significant, pardon the pun, because they tell us about the degree of accuracy we have chosen. So yes, these are the same number, but it's written differently depending on how many significant figures we set the rounding to. And we'll go one more example. Whoop, it's not what I want. Let's round this to 2 significant figures. And you will see that, well, now we have our second significant figure, 1, 2. And the number on the decimal is 5 or greater. So we're going to round up. So what's going to happen here is, well, our decimals leave because we don't need them anymore because we're doing a more vague, well, a more broad approximation. So the decimals aren't necessary to us anymore because we want something to 2 significant figures. I know this is a bit of a brain melting idea because we're the ones in control. We're sort of stating the level of accuracy we want. But if hopefully these examples have helped to give a little bit of context to significant figures and why we use them. And you'll get the hang of it the more of these questions you work through. So that is significant figures in a nutshell. These are them in terms of decimals. And we can see we have slight differences to whole numbers when we work with these. But good luck working through all of these in your own time, and I will see you guys in the next video.